Hello everyone, welcome back. In previous lecture, I explained about the micrometer and how to take reading in micrometer. Now, in today's lecture, I'll be discussing about the sources of error in micrometer, then precautions to be taken, and what are the various types of micrometer. So, let us start. So here the sources of errors in micrometer are total six types of error are there. Here you can see. So the first type of error is the face of anvil and spindle may not be truly flat. So in micrometer, if the faces of the anvil or spindle are not true, then there is possibility of error in it. Another error is lack of parallelism or and squareness of anvil or spindle at the sum or all parts of the scale. What it means that the spindle or the anvil is not parallel with each other. Okay, so at that time the parts of the scale will not be matching. Okay, so there can be the chances of error. Then third type of error is setting of zero reading may be inaccurate, which means the first we have to start off with the zero reading. If there is some error or burst in it, then there is chances that there will be error in it. Another error that can be possible is the inaccurate reading have shown by the fractional division on thimble. So what happens when we are uh, taking reading? We count the thimble marking, but if the reading have shown by fractional division, okay, so there is chances of inaccurate reading. Another source of error is wear on the face of anvil and spindle and wear in the threads of spindle. So there may be chances of wear on the faces of anvil and spindle due to repetitive use in industry or in workshop, and there may be wear in the threads of the spindle. So due to that, there is possibility of error in it. And error due to too much pressure on thimble or not using the ratchet. So basically the ratchet is provided that it knows when the uh, spindle or anvil is in completely contact with the workpiece and there is uniform pressure, and it stops at that particular position. But if we don't use that ratchet or the we apply too much pressure on the thimble, then there will be error in the measurement. So these are the various sources of error in micrometer. Next, these are the various precautions to be taken while using a micrometer. So the micrometer is available in various sizes and ranges. As we know that there are various size and ranges of the micrometer, and corresponding micrometer should be selected depending upon the size of workpiece. So it is depends on the how the large diameter of the workpiece is there or the length we are supposed to measure. So depending on that, the inside bore if we want to measure or anything we want to measure, the size varies of the micrometer depending upon the workpiece size. Okay, so the micrometer should be cleaned on any dust and spindle should be moved freely. Okay, so to compensate the error caused by the dust or to eliminate it, we have to clean it of any dust and spindle should move freely. Third thing which is important is to check and set the zero reading before measuring. Okay, so before starting any reading, check first that the zero reading is coming or not. Fourth one is workpiece whose dimension is to be measured must be held in left hand and the micrometer in the right hand. So this is very much important, as you know that the most of are right handy, and the micrometer is also made in such a way that if you hold in a right hand, it will be more effective way to that you can measure the dimension accurately. Okay, so another one is make sure that the dimension to be measured in parallel to the axis of spindle and anvil. Now next thing what we have to make sure that the डायमेंशन टू बी मेजर्ड, जितने भी डायमेंशन हमको मेजर करने हैं वो एक्सिस के पैरेलल है ऑफ द स्पिंडल एंड एनविल. ठीक है, अगर वो इंक्लाइंड हो गए तो देयर विल बी पॉसिबिलिटी ऑफ एरर इन certain extent. Okay, always use the ratchet for final adjustment and lock nut for taking readings. As I mentioned that the ratchet are used for applying the uniform pressure, so always we must use the ratchet and lock nut for taking readings. In case of measurement of diameter, make sure that the anvil and spindle faces touch the maximum dimensions only. So in measuring the diameter, make sure that the anvil and spindle faces touch the maximum dimension only. So जब भी हम diameter measure करेंगे तो उसमें सबसे important क्या है कि जो anvil और spindle है उसकी जो faces है वो maximum dimension को touch करे. ठीक है, अगर minimum dimension पे touch किया होगा slightly above slightly below, then there will be possibility of error. So these are the various precautions which must be taken care while using micrometer. Now let us see what are the various types of micrometer. So there is number of different micrometers available for specific application and accuracy. One is outside micrometer, second is inside micrometer. The earlier we have seen was the outside micrometer that is used for measuring the outside dimension, while the inside micrometer is the used for the inside measurement. Then there is vernier micrometer. Then depth micrometer is used to measure the depth. Then there is bench micrometer, digital micrometer, differential screw micrometer, micrometer with dial gauge, and screw thread micrometer. So these are the 9 types of micrometer. Okay, so basically the vernier micrometer includes the outside or inside, it can be any of this. Okay, while similarly the digital micrometer can also be the outside, inside, vernier or depth micrometer as well as. Okay, while now let us see the first one, the outside micrometer we have seen. Now let us see first with the inside micrometer. So this is the inside micrometer which is used to measure the internal dimension of the workpiece. It majorly measures the internal dimension, and a figure shows that the inside micrometer and the construction is similar to outside micrometer. However, the inside micrometer has no U-shaped frame and spindle. The measuring tip are constituted by jaws whose faces are hardened and ground to the radius. So the faces are ground to the and hardened to the, here you can see these faces are ground and hardened so that they can be measure the inside dimension. These are the two various types of. First one is having the this measuring jaw, and second one is having the end portions of or anvil. These are the two separate types of inside micrometer. Okay, so this one is used for smaller inside dimension measurement, while for measuring the large dimension we can use this type of inside micrometer. The range of these micrometers is 50 mm to 200 mm. This one, this having jaw. However, the range can be increased by extension of the rod provided with it. Okay, so micrometer has nose, frame, and spindle. Measuring point are at extreme ends provided with the anvil, and the axial movement of end point is taken place by thimble rotation about the barrel axis. A series of extension rods are provided in order to obtain a wide measuring range. Before taking the measurement, appropriate internal dimension of workpiece whose dimension is to be measured, or the inside micrometer, is measured by scale. Okay, the extension rod is then selected to the nearest one and insert in the micrometer head. दिस इज द एक्सटेंशन रॉड. सबसे पहले क्या करेंगे कि स्केल लेंगे और स्केल से पहले एक रफ डायमेंशन इसका मेजर कर लेंगे, फिर एक्सटेंशन रॉड को हम एक्सटेंड करके यहाँ पे फिर उसको वहाँ पे फिट कर सकते हैं. ठीक है, और फिर उससे हम मेजरमेंट कर सकते हैं. ठीक है, then the micrometer is checked for zero error with the help of standard size specimen whose internal dimension is known. Now the micrometer is then adjusted at dimensions slightly smaller than the internal bore dimension or the diameter of workpiece. The micrometer head is then held finely adjusting the bore as well as shown in the figure, and other constant surfaces adjusting by the moving the thimble till the correct fill is sensed. The micrometer is then removed and reading is taken. The length of extension rod and collar are added to the micrometer reading. So in this way we can use the inside micrometer for measuring the workpiece inside diameter or inside dimension. Okay, the measurement process is similar, and the least count is the minimum reading on main scale divided by the thimble number of division on thimble or auxiliary scale. Okay, so suppose the point 0.5 is the division over here and there are 50 division, so it will be 0.01, the least count of vernier. Okay, micrometer, and here also if the same is there, then we can find the least count. This is about the inside micrometer. Now next is vernier micrometer. So here you can see this is a simple vernier micrometer, or it is also an outside micrometer. But the specific thing over here is that the in order to increase the accuracy, the vernier principle also be applied to outside micrometer. Now here, to increase the vernier which means the accuracy of the micrometer, the vernier scale or vernier principle is applied to an outside micrometer. Here you can see there is extra vernier scale as in the vernier caliper we have seen that. Okay, so this type of micrometer can read by 0.001 mm. So earlier it was able to read up to 0.01. Okay, now it will can read up to 0.01 mm. Now the vernier micrometer has three scales. First one is the main, second one is auxiliary, and third one is the vernier scale. The main scale is graduated on the barrel with two sets of division mark. Here the main scale, and the set below the reference line in mm and set above the line reads in half mm. Okay, so the set below the reference line in mm and set above, here you can see the below lines are of mm lines and above half my marks are for the half mm mark. A thimble scale is graduated on thimble. Here with 50 equal division. Each small division of thimble represent 1 by 50th of minimum division on main scale, and the main scale division value is 1 half mm. Okay, so here the 1 half mm is the main scale reading. So for 1 half mm there is equal 50 division of this. Okay, so vernier scale is marked on the barrel. Here you can see the vernier scale is marked, and there are 10 divisions on barrel, and this is equivalent to 9 division on thimble. Okay, so this is equal to, these are 50 division, but for 9 division it is equal to the 10 division on the barrel. So the inside spindle, this is the barrel, and this one is the thimble. The outside thick part, this part is the thimble. Don't confuse between these two. Okay. Vernier scale is marked on barrel, and there are 10 divisions, and one division on vernier scale is equal to 9 by 10th of thimble. Okay, but one division of thimble is equal to 0.01 mm. Therefore, one division on vernier scale is, we can measure the least count of vernier micrometer is the value of smallest division on thimble. Here the value of smallest division will be equal to 0.01, and the value of smallest division on vernier scale will be 0.009. Okay, so it will be 0.001 mm. So it is the accuracy of vernier micrometer. And we can also measure uh, any dimension from it with reading the main scale reading, then thimble reading and multiplying with the least count of thimble, then vernier reading and multiplying with the least count of vernier and adding all three readings. Okay, readings of three scales are added to get the final dimension. Okay, so, so we can measure with help of vernier micrometer. Now, next one is about the depth micrometer. Here you can see the depth micrometer. This is the base, and this is the measuring face, and this one is the moving spindle. And here you can see there will be dimension to be measured, and this one is the barrel, this one is the thimble with auxiliary scale, main scale, or reverse scale, and this one is the ratchet. Okay, now the all the parts are similar, but the main difference here it is there is the one moving spindle and a baseline. The base is very flat or highly finished surface, and which is used for making the micrometer parallel with the workpiece, so that it can hold or stay on this surface very nicely. Now the depth we are supposed to measure is, here you can see how the depth micrometer is inserted in the hole in which we wants to measure the depth, and the main scale reading and auxiliary reading or thimble reading is taken to take the reading. Suppose the main scale reading, here you can see 15 or 16. Okay, there will be 15 and half, so we can read it, or here you can see also there is one reading as well as, so you can find how it is calculated. Here there is 5, so it will be 0.05, so it will be, here it will be 15, and here it is 16, so it will be 16 plus 0.5, so it will be 16.05. Okay, so the depth micrometer is available in a range of 0 to 25 mm or 0 to 50 mm, and the range can be increased by up to 0 to 90 mm by using extension rod in steps of 25 mm. So there are steps of 25 mm, and extension rod can be used. An extension rod can be easily inserted by removing the spindle cap. Now, this is about the depth micrometer. Next one is the differential micrometer and digital micrometer. Let us see first the digital micrometer. We will discuss the differential micrometer in the next lecture. The digital micrometer is only having one digital indicator which directly reads the reading, which is similar to this vernier micrometer, and this is having only the simple on off buttons, so or reset button, so we can take the reading with the simple use. Okay, so the let us keep today's topic to up to here. So we discussed about the depth micrometer, vernier micrometer, then inside micrometer, then various types of micrometers, precaution to be taken care, and sources of error in micrometer. So this is it for today's lecture. Thank you very much for listening me carefully. Have a nice day.